Greetings and welcome to episode 24 of the Sustaining the Herd podcast brought to you by Agri-Services and Engineering of Raymond, Nebraska. I'm Andrew Wadle and I'm joined in the studio by my co-host, Brock Vitek. Good afternoon, Brock.
Good afternoon, Andrew.
So for our returning listeners, we really appreciate you coming back. Hopefully you're finding information that's useful when it comes to sustainability in animal agriculture. And then also we'd like to welcome our new listeners who, for those new listeners, what are we all about? Well, we are all about sustainability in animal agriculture, and sustainability can mean so many different things. And really, the three pillars of sustainability that we tend to recognize episode to episode would be, well, first, environmental sustainability. That is minimizing the impact of animal agriculture, keeping manure or nutrients, et cetera, out of our air and water. Everybody wants clean air and water. It means maximizing resources, doing more with less. That is sustainable. That is sustainability. And then lastly, but certainly not least, would be sustainability of businesses. We have to have businesses that are profitable and in order to be remaining in business. And so businesses are businesses. And so we want to help businesses be sustainable. We have a passion for animal agriculture, and we want to do everything we can to promote the sustainability in animal agriculture. And so with that, right now we talk about so many things with animal agriculture when it comes to manure, right, Brock?
We do.
And so one of the topics that we always weaves in and out of our projects here at Agri-Services and Engineering is manure solid separation. That is separating manure solids from manure liquids. And this is something you have a keen interest in, isn't it, Brock?
I sure do.
Yeah. And so what I thought we would do in this episode is, Brock is reasonably new into this industry. I'm a bit more seasoned, as you can tell by the gray hairs and less of it. And so what we thought was maybe this would be a good episode for Brock to continue to get spun up on the subject of liquid solid separation in manure. And there's a really, really good chance that the things that he's interested in learning about in manure solid separation is consistent with the things that you as our listeners are interested in knowing about. And so this is going to be, I don't know, kind of like a stump the chump, Brock. Like you can ask me questions and maybe this is going to satiate your interest in all of the things you'd like to know about solid separation.
Sounds good. Let's roll with it.
Yeah. All right.
Okay. Well, Andrew, I'd like to kick off the conversation by asking you what are the biggest myths out there when it comes to manure solid separation?
It's a long and distinguished list, Brock. It really, really is. There are a lot of myths when it comes to solid separation. And maybe before first going into the myths, it's important to talk about really what is manure. Because if you understand what manure is comprised of, you can start, by the time this episode is over, you and our listeners will kind of be able to start debunking some of these manure separation myths.
Sure.
And so, first of all, why do people separate manure? Well, it's usually to simplify the handling of manure, so we can separate out the fibrous particles from the liquid particles. And when we do that, the solids may have a beneficial use and the liquids may have a beneficial use. But when you take that manure as it's excreted and subsequently diluted, manure is always diluted, whether it's on a dairy with milking parlors or whether it's on a feedlot with runoff from rain. Manure is always diluted, or most often diluted. And so when you look at manure, it is comprised. If you look at it on the most basic level, you have solids, or some people call it dry matter, and then you have liquids, and liquids are liquids. And then if you break down the subset of solids, the solids can then be classified as dissolved solids or total dissolved solids and total suspended solids. And the total suspended solids are basically everything greater, everything that's not dissolved, right? So, or look at another way, the total dissolved solids are all the solids that are dissolved in the liquids, and really the way that's technically classified is it's everything smaller than 1.5 microns. It's everything smaller than 1/17,000th of an inch, and so we have dissolved solids and we have suspended solids. As you can imagine, at 1/17,000th of an inch, you're talking about stuff that's really, really small, and then you have everything that's larger. And so you can imagine it's really, really tough to capture. You can only imagine what it's like to capture a particle that's 1.5 microns.
Yeah, that's pretty small. We're talking about 1/17,000th of an inch, isn't it?
Yeah, absolutely, absolutely. So so think about it this way: if we were going to want to screen, here, put it in perspective: a window screen, your typical window screen is 1 millimeter, maybe 2 millimeters, probably more like 1 millimeter. And if you were to take water, pure clean tap water, zero dissolved solids for all intents and purposes, zero suspended solids. If you pour tap water across a window screen, it would really just hold up on the window screen. And just because of the surface tension of the water going through the wires.
Mm-hmm.
And so you can imagine just right off the bat, boy, it's pretty tough to screen smaller than 1 millimeter just because of the surface tension of water. And so
Mm-hmm.
that's a real challenge.
Sure. Yeah. Well, Andrew, thanks for the what I'll call manure solids 101, just understanding some of the fundamentals and the basics of what what it means when we're talking about solids and manure. So now let's maybe jump into some of the myth busting here. And my next question I'd like to ask is, how does the relationship between the different types of solids and the makeup of the solids in manure affect how it separates?
Right. Okay. You know, so I'll call myth number one is that very, very high rates of solid separation or high solids capture can be achieved. And so getting right down to it, if with a manure slurry, if you're getting 30% solids recovery, okay, 30%, that's pretty impressive. That would actually be considered reasonably high, a high recovery. And why is that? It's because you can only screen. Going back to my previous comment, you can only screen so small that when you're separating by size and you're separating down to say a millimeter, you can only capture particles so small. And it just so happens that manure particles a lot of them are really, really fine. And so people will go out to a dairy and they'll see this huge pile of solids underneath a separator and thinking that's like they're capturing them all. When as it turns out that they're capturing maybe 30% of the solids. And so
Mm-hmm.
that's myth number one, is that what I would call myth number one of many is solids capture is lower than what people tend to expect. And so also the solids capture can be a function of how dry you capture the solids, because the the harder you squeeze, right? So let's just say we're making bedding. There's a chance that the harder we squeeze something, that our capture can actually go down. Whereas we're making a high quality product that is a high solids material, we could actually end up in that process, forcing solids into the liquid stream. And and the liquid stream is really important because of the fact that we have that that percentage of dissolved solids. If they're dissolved, you're not going to screen them out in typical separation equipment.
Sure. And you just said something there that stuck out to me. I think that people can often unintentionally get the impression that separation systems are somehow antimatter machines. But as you said, there's the solid and there's the solid fraction and the liquid fraction coming off of the digester. So as we think about liquid, or I might just say water, how is that managed in separation, and where does that water or that liquid go if it's not an antimatter machine?
Yeah, you and I joke about that all the time, right, Brock?
Mm-hmm.
That when it comes to digesters and manure separators, there's some reason people think that they're antimatter machines. Like you push a pound in and you get a half a pound out, and the
Mm-hmm.
rest, the other half pound goes into the ether or something. But
You,
no,
you,
you've got it all.
if we actually did come up with an antimatter machine, we'd probably have more listeners than we do, right?
I think we would, and we probably would be on an island somewhere, bro.
Exactly. But anyway, go ahead.
Yeah, yeah, so yeah, I would call this the thickening myth, and this is more of a myth that's geared towards digesters and digester operators, because so we have this this really dilute slurry, and we want to get it as thick as possible, right, to go into a digester.
Mm-hmm.
And so the digester folks are really, really happy when we get total solids of, I don't know, 10%, 8, 10, 12%. That's kind of really, really where they want to be. And so it's so where the myth comes in is, well, if we have a slurry that's 4%, okay, if we want to get that slurry to 12%, well, we can sure do it. You can produce an effluent that's 12%, that's digester ready, be tailor-made digester effluent. But the challenge becomes back to myth number one, and that is, well, we only captured 30% of the solids to get to that 12%. And that remaining 70% of the solids are now ending up in the liquids. And so the liquids, they're the part that everybody hopes goes away, but not only does it not go away, but it contains a significant portion of solids. There's more solids in the liquids than there are in the solids, if that makes any sense. But that is just the reality of separating this material by size, as we'd say.
Yeah, that makes sense.
So for our digester friends, this is something that we really have to be cognizant of, is when we're talking about thickening manure, that's fine. We can definitely produce a thick product, but what about everything that's still left in the thin product? Because it surely is a quantity that you want, particularly when you want maximize volatile solids capture going into a digester.
Yes, very much so. And that leads me to my next question. We know that manure is made up of a few things. There's water, for sure, and there's organic matter, or VS, volatile solids, as our digester friends will be familiar with. And there's ash, which is inorganic matter or fixed solids, and that contains mineral content, grit, nutrients, a lot of things. And I'd like to ask about nutrients specifically, because nutrients are also being separated out during the solid separation process. Some are going to report to the liquid, some are going to report to the solids coming out. Could you help me understand that better, as well as our listeners?
Sure. And so when you look at the nutrients, it kind of goes back to looking at the solids. When I said, when people go out to a dairy and they see a huge pile underneath a solid separator. It's just that you just naturally think, well, gosh, well, there's all the nutrients. Well, as it turns out, that is really not the case. The solids that you capture, they're not necessarily inert. They do have a some nutrient value associated with them, but the nutrients by far report to the liquids. Okay, and so we tend to say that the nutrients follow the mass. Okay, so the majority of the mass that goes into a separator, the majority of the mass goes to the liquids, and so fewer nutrients go to the solids. And so so that's we can call it myth number 3, and that is solid separation produces a nutrient dense fiber product,
Mm-hmm.
when in reality that fiber product is very, very low in nutrient value. It has some nutrients, but not all that high. The vast majority of the nutrients will report to the liquids, and so that's really a big myth that folks tend to ascribe to. And if you look at a gross mass balance about a separator, you're usually looking at, and this is going to depend on the solids content going into a separator, but usually the mass breaks about 30%. 30% is like the magic number here. About 30% of the mass will report to the liquids. 30% of the mass will report to the solids. And so, so the nutrients, be looking to the liquids for your nutrients. For instance, phosphorus tends to be associated more with a colloidal material. Well, if you go back to the window screen analogy, you're not going to capture something colloidal through a window screen. And I just want to keep on emphasizing that we're up to this point, we've been talking, and with all practical solid separations on dairies, we're talking about separating by size. And when you talk about separating by size, that's where we start running into this bottleneck of how small can we capture and still have a reasonable capacity through a piece of equipment.
Sure. And just for our listeners, I think a good analogy or an example of a colloidal mixture would be milk. If you went and tried to pour milk through a window screen, it's not like you just get water coming out the bottom and your milk powder solids are on top. It just doesn't happen. That's going to stay together.
Yeah, that's exactly right. That's exactly right.
And so another thing I'd like to, or not a question, but just a follow up to that, Andrew, would it be safe to say that nutrients are dissolved solids for the most part in manure if they're reporting to the liquids rather than suspended and being pulled out?
In large part, the nutrients would be more associated with the dissolved solids. That is correct, Brock.
Okay, awesome. Well, we've busted a few myths. I think we can probably come up with another one here. And so the next thing I'd like to say is I think it's safe to assume that not all separation systems work the same. So, with that in mind, how should a producer go about selecting a separation system that would fit their operation and their needs?
That's really that is a fantastic question, Brock, because when we look to digestion systems, you've seen enough digester plans to know that usually, like, every single one will have screw presses associated with them. And so a screw press for our people in town, our friends in town, or who aren't ag people, who don't really have any familiarity with solid separation at all, a screw press is, you can think about it as an extruder. And so a manure slurry is pumped in, and an auger or a screw is pushing the separated solids through a screen. And so they make super, super, super dry solids. And so they'd be very, very, you'd expect to see them with it on a dairy, if you're going to make bedding, okay? And so getting right to your question, Brock, to answer your question, you have to look at what are you going to do with manure. And so, like solid separators, they're not like Kleenex. A Kleenex is the same. This brand is the same as that brand. All solid separators are a little bit different, and they serve a different purpose. And so, it's a matter of saying, what am I going to do with that manure? Because some solid separators are better suited to do other things. So, for instance, screw presses, as I was just kind of alluding to, they are the say the piece of equipment of choice for producing bedding where you need to get, say dairy cow bedding, you need to get that material as absolutely as dry as possible, because moisture is the enemy of bedding, which becomes the primary cause of mastitis in lactating dairy cows. And so, if we're going to be bedding cows with separated solids, it has to be as dry as possible. However, if we are simply separating for the purpose of what we'd call water quality, if we're just looking to get solids out of get solids out of a slurry in order to maybe make the manure slurry more amenable to manure pumping, we'd probably be looking at a different piece of equipment, something more like a rotary drum separator. And why would we make that distinction? The distinction would be dryness comes at a cost. Okay,
Mm-hmm.
dryness comes at a cost, and those costs are two. The one cost is you have a capacity issue. So the material stays in the machines longer, so to speak, because it has to stay in there because we're pressing the heck out of it, we're pressing the crap out of it, literally. And so that becomes that becomes a primary limitation. And with that limitation, you also get it has a cost. And so these screw presses would generally be a higher maintenance item as compared to, say, a rotary drum separator. But again, that's not saying that it's a negative about screw presses, because it is, it's like when you need a tool to do a job, you need a tool. If you need a Phillips head screwdriver, you need a Phillips head screwdriver. Nothing else will suffice.
Mm-hmm.
Well, I guess you could have, if you're kind of a bad mechanic, you could use a flathead screwdriver. Maybe that's not the best analogy, but I think our listeners know what you mean. When you know what I mean. When I need a particular tool for the job, you need a particular tool for the job. So, and in the case of making bedding, a screw press would be it, but it comes with some challenges. On the flip side, if let's just say we're into that deal where we're just looking, we need just to knock a lot of solids out in order to say drag line manure, and well, in those cases, well, we don't have to make a material that's so dry, or let's just say we're separating out solids so that we can recycle water in a flush flume. We don't have to make solids that dry. We need to get out just enough solids so that the water doesn't have material in it that will inhibit its ability to be pumped or to be used for cleaning. And so say rotary drum separators would be you would typically not produce bedding with them. Not always. There are definitely exceptions when they're hooked up with, say, a roller press or something, but primarily it's a different tool for a different job. Now, and so you wouldn't use a screw press, say, for producing water for a flush flume or something like that, because again, the capacity isn't quite there. So it's really a matter, Brock, or you can put sloped screens as another high capacity
Mm-hmm.
solid separator that would be used for producing higher quality water.
Mm-hmm.
So really, the short answer to your question is, hey, it's really a matter of looking to what do you want in terms of your outputs. Are you making bedding? Yes or no. Are you producing? Are you thickening? For a digester, it's perhaps something different.
Sure. No, thanks for that great answer, Andrew. You laid it out very well to help us understand when, a certain type of separator might be applicable and when it's not. And so I'd like to zoom out and look at the bigger picture of when a livestock operation, whether it's dairy or swine for our purposes here, has a digester. Is there ever an instance where the livestock operation will separate the manure, maybe for recycled flush, for example, and then for the purposes of the digester, there might even be some more dilution that takes place, and then we're going to separate it again on the back end with the digestate?
Yeah, Brock, I would call that quite common in the digester world, and that is the model that we'd call the thickening, where well, there's two things that's happening. One is we have a digester. The other is we're using liquids to do some work, and those liquids, the work that those liquids are doing is conveying manure, almost like a sewer. So the manure will be scraped into a pipe, and that pipe will be charged with water, and not pure clean tap water, but that the pipe will be charged with recycled manure water. And that's where the thickening part comes in, where, well, when the manure, as soon as the manure gets scraped into this pipe, it gets mixed in with water, and all of a sudden it's really, really dilute. And so by virtue of the conveyance process, we've taken the manure apart, right? And we've made it really, really dilute. And that's not really good for the digester. But so then we'll go through a solid separation piece, and we'll take the liquids off that separator, and we'll use that water, and we'll recirculate it back through the digester, or excuse me, back through the flume in order to convey the manure. And then we have this, what we would call this thickened product, right?
Mm-hmm.
But then going back into the digester, we do want some of those solids that were in those liquids. We want those to go into the digester as well. And so we do end up blending. We could end up blending the solids and some of the liquids back together in the interest of getting as many solids going forward into our digester. So dilution took the manure apart. We put it back together to some extent. Then the manure goes through anaerobic digestion. The anaerobic bacteria populations then degrade those solids. We make biogas. And then what comes out of the digester now is solid separation, where we would then make, if we're talking dairies and potentially feedlots, we would be producing a dry separated solids. And when now those solids are out, we're going to keep them out. And then we're going to produce a liquid fraction that would then be irrigated with crops. And so the question you asked is illustrates an example where you could have a rotary drum separator, say, producing water at a high volume to run a flush flume, and then would also separately have a screw press that would be making solids for bedding. I hope that answered your question.
Yeah, you answered it for sure. I wanted to get the point across that sometimes we might be pulling manure apart and putting it back together, and doing that a couple or a few times throughout the process for various purposes. And just wanted our listeners to understand that.
Well, and I think that's one of the keys here, is that how many times do we say, Brock, that agriculture is the greatest recycling system the world has ever seen? Because dairy producers they want to recycle and reuse everything they can, and so it's if we're going to use water to convey manure, it's going to be recycled water. It's not going to be fresh water in the interest of conserving all of our resources.
Yep, you hit the nail on the head.
Yeah.
So, Andrew, my final question I have for you, I'd like to take a look ahead and ask, what's the future for separation systems?
Well, the future for separation systems really involves getting out as many solids as possible, and recognizing the fact that, remember we said, if we can, the more solids we get out, with some of these advanced treatment systems I'll get to, we're going to get out the nutrients as well. So I guess if everybody, the perfect world scenario would be to produce discharge quality water. And so can you take manure and produce discharge quality water? Absolutely. And I do say absolutely because I've seen it done. And there's people that drank the water that came out of manure. And well, how do you get there? I mean, it's not that simple. It's not a screw press. It's not a rotary drum separator. And so the systems that we're seeing that hold the most promise would be a step where you would have some kind of a solid separator first, screw press, rotary drum, etc. And then you'd go through another stage of separation that would be called something like membrane filtration. And so with the membrane, I'll keep coming back to the analogy of the window screen. How, if you want gravity to pull water through a window screen, or even if you take manure that's viscous, you're waiting a while for that water to go through that screen. Well, if you go to membranes, you have a very, very fine, very, very small opening. And so I should know the exact size, but I don't. The way you get a liquid with solids through a really small opening is you pump it through. You literally force it. You literally force the liquids through the openings. And so membrane filtration, or people will call it ultrafiltration, that has a tremendous amount of promise for removing all of the suspended solids. Remember, going back to the first myth or the description of manure to begin with, we have dissolved solids and we have suspended solids. So membrane filtration will separate out, for all intents and purposes, all of the suspended solids. So that's huge. The next step, we can still take it farther, and taking it to the next step would be reverse osmosis, just like some people have reverse osmosis in their house. And so reverse osmosis would be the next step, which would be even a smaller filter. And so now we're getting out the dissolved solids. And so after what I'll call conventional solid separation, screw press, rotary drum, then we have ultrafiltration. We're going to get out the suspended, and then we go to reverse osmosis, and we get the dissolved. What you get at that point is a product that's still not direct discharge quality, but it's pretty far down the road. So what we're going to see, I believe, and there are some of these systems out there, I've seen them, incredibly impressive. It's just like anything else. The more it's done, the costs will come down. And when the costs come down, it's going to be a chicken and egg. And you'll start seeing these systems in more and more places. And I'll say, just going back a step, even before we get to membrane filtration, ultrafiltration, there's a step that we kind of didn't mention, is centrifuges. And centrifuges aren't I'll say they're a size-based separation, but with the assistance of enhanced gravity, where we're so we take a particle and it's settling. Let's say it's settling in a rotary drum separator. It's settling under 1G. We're all experiencing 1G, right?
Mm-hmm.
When you pump through a centrifuge, this drum that's turning at call it 1,000 plus revolutions per minute, you're subjecting a particle to 1,500 Gs, and so that is pulling the particle, pulling the suspended solids out of a slurry, and so that's another way to get out more solids. And that's being done on a pretty, I'll say those systems are tried and true, and operating quite successfully on a large scale on dairies throughout the United States. So that's just another type of separation system to be thrown into the mix with screw presses and rotary drums.
Sure. Well, thanks for that look ahead at the future. I think you're right, and we'll continue to see systems get developed and get better and more economical as time goes on. Well, I have to tell you what, Andrew, this has been a really fun discussion. I hope you've enjoyed it as much as I have.
Oh, Brock, I appreciate just talking about it, and we just want to do everything we can to help help our industry and help everybody in our industry just understand what the limitations are, what these myths are, because we want to see every system be successful, because successful systems result in more successful systems.
Yeah, exactly. It's kind of fun for me. This is the kind of what I'll call coffee conversation we have on a daily basis. So it's fun to hit the record button for this one and just give our listeners a little bit of insight on the types of conversations that happen at SETI Agri-Services every single day.
And if our listeners have any other questions, want a little bit any more details, by all means, drop us an email, and we'll be glad to visit with you.
Yeah, and if they want to do that, they can do that at podcast@sechi.com. Feel free to send us a note. And as we wrap up the discussion, I would just like to go down the quick laundry list of myths to do a very brief recap here for our listeners. With that starting out at myth number 1, is that solids recovery is often lower than people might anticipate because we're only capturing the suspended solids for the most part, not really the dissolved solids.
Yeah,
And then
we might capture some dissolved solids, but those dissolved solids would only be the liquids that are attached to those solids that we capture.
precisely, they'd be surrounded by liquid.
Yep. Because every single one of those manure particles, think of it as a sponge, right? And
Mm-hmm.
so that sponge is absorbing, those little manure sponges are absorbing liquids, and in those liquids are the dissolved solids.
Exactly. And then myth number 2, when you thicken manure, you're not running an antimatter machine. There is a thin or a liquid stream that's coming off as well, and that has to go somewhere and be utilized somehow. It's not like the water just disappears.
Yeah, and for our digester friends, it's really simple. If you want to keep water out of your manure, keep water out of the manure. That's the easiest way to do it, because once you take manure apart by dilution, it's really tough to put it back together to where it was and where it started.
It's like putting in too much salt or pepper when cooking. It's a lot easier to put more in than to take it out, right?
Absolutely.
Then we have myth number 3, that nutrients primarily report with the liquids and not the solids. The nutrients follow the mass is our rule of thumb that we like to say. Nutrients being things like nitrogen, phosphorus, and potassium. And then finally, myth number 4, not all separation systems are created equally, nor should they be, because different system designs have distinctly different purposes.
That's absolutely right. Every system has a different purpose. They perform differently and for different reasons. It's funny. People say, "Well, gosh, I want super high super high recovery." Well, if you think about it, anybody could have 50% solids recovery, and that would be if you have a pipe and you put a divider in that pipe and you split it 50-50, you'd get 50% solids recovery. But the solids wouldn't be of the quality that you would desire. And so it's a matter of understanding what it is that you want in those solids and choosing your equipment accordingly. I'll also say to folks out there who are contemplating systems, also take into account what you would have for dealer support, because having a dealer to support whatever type of equipment you purchase is really, really key.
Precisely. With all of that, I think we'll wrap it up if that sounds good, Andrew.
Sounds good, Brock. Hope to hear from our listeners.
Yeah, same here. And to all of you, our listeners, we thank you so much for joining us today, whether you're a new listener and this is your first episode, or if you're a returning listener. We're grateful for all of you. And we look forward to being back with you again in a couple of weeks with another episode. Until then, thanks for joining the herd today.
Thanks, everyone.